tomorrow morning, you're going to walk outside, look up, and see a blue sky. It's an undeniable, universal truth. It's one of the very first facts you learn as a child. But for almost the entire span of human civilization, that blue sky did not exist. If you could travel back 3,000 years and point to the morning sky, the people standing next to you wouldn't see blue. They wouldn't even have a word for it. To them, the sky was a blank expanse, a dark shadow, or the color of wine. Modern humans take color for granted. We assume our eyes are windows, cleanly reflecting the world exactly as it is. But the reality is far stranger, because your ancestors weren't just missing a word for blue. They were functionally blind to it. Your brain doesn't just see the world, it builds it. And for thousands of years, the human mind simply chose to leave blue out of the picture. The discovery of this blind spot began with a man who wasn't even a scientist. In 1858, William Gladstone, a brilliant scholar who would later become the Prime Minister of Great Britain, was deep into a study of Homer's Odyssey. As he read through the thousands of lines of epic poetry, he noticed something bizarre about the way Homer described the world. Homer was a master of imagery. He described the texture of clothing, the gleam of armor, and the specific details of animals. But his colors were completely wrong. He described the ocean as wine dark, not blue, not even green, but the deep, murky purple of a cup of wine. He described oxen as purple. He described the sky as metallic or copper or iron-colored. Intrigued, Gladstone went through the entire text, counting every single color reference. Black was mentioned nearly 200 times. White was mentioned 100 times. Red appeared 15 times. Yellow and green made rare appearances. But blue? Blue didn't appear a single time. Not once. In a massive epic set entirely on the Mediterranean Sea under a massive open sky, the word for blue was entirely absent. At first, Gladstone wondered if Homer was simply blind, but historical record showed that Homer wasn't an anomaly. Gladstone expanded his search to other ancient Greek texts. The result was exactly the same. The ancient Greeks lived in a world of blacks, whites, reds, and yellows. They had no conceptual space for blue. The world ignored Gladstone's findings for years, assuming it was just a quirk of ancient literature. But then, a German philologist named Lazarus Geiger decided to see if this was unique to Greece. He analyzed ancient texts from every major early civilization. He dug through the ancient Indian Vedic hymns. He read through the Icelandic sagas. He studied ancient Chinese scrolls. He analyzed the original Hebrew texts of the Bible. What he found shook the foundations of linguistics. Every single ancient culture followed the exact same evolutionary path for color. In every language, the words for color emerged in the exact same order. First came black and white, or dark and light. Humans needed to distinguish between night and day. The very next color to get a name in every single culture on Earth was red. Red is the color of blood. It is the color of fire, of danger, of life itself. It's a color you cannot afford to ignore. After red, languages developed a word for yellow, followed closely by green. And at the very end of the line, thousands of years after the others, came blue. The only ancient civilization that developed a word for blue early on was Egypt. And they were also the only civilization that knew how to manufacture blue dye. For everyone else, blue was a ghost. But this raises a frustrating question. Just because they didn't have a word for it, does that mean they couldn't see it? Were their eyes physically different from ours? To answer that, science had to look outside the history books and find a living test case. In the late 20th century, Researcher Jules Davidoff traveled to Namibia to visit the Himba tribe. The Himba people live a traditional lifestyle, and their language is unique. It has no word for blue, and it groups green and blue under the same category. Davidoff conducted an elegant experiment. He placed a computer screen in front of tribe members, showing a circle of 11 green squares and one distinctly blue square. To a modern Western viewer, the blue square leaps out immediately. It looks completely out of place. But when the Himba were asked to point out which square was different, most of them couldn't do it. They stared at the screen, baffled. Those who did guess took a long time and made frequent mistakes. Physically, their eyes were identical to yours. The photons of blue light were hitting their retinas in the exact same way, but their brains couldn't process the difference. Then, Davidoff ran a second test. He showed them a circle of 12 squares. This time, 11 were a specific shade of green, and one was a slightly different, subtler shade of green. To you or me, the circle looks entirely uniform. The difference is practically invisible. But the Himba looked at the screen and pointed to the different square instantly. The experiment revealed a profound truth about human consciousness. Language doesn't just describe our reality, it limits it. It categorizes the chaos of the world into neat little boxes. If your culture doesn't provide a box for a specific sensation, your brain works overtime to smooth it over, erasing the distinction entirely to save energy. Think about how a baby experiences the world. A newborn doesn't see a room full of distinct objects. They see a swirling vortex of raw sensory data: light, shadow, texture, and noise. As they grow, they learn labels. That's a chair. That's a window. That's a dog. Every label acts like a fence, separating one concept from another. Before we gave blue its own fence, it was just a strange shade of green, or an extension of the dark sky. And because it didn't matter for survival, the brain ignored it. Look around nature. Red is everywhere. Berries, blood, venomous insects. Green is food, shelter, and terrain. Yellow is the sun, ripe fruit, and predators hiding in the grass. But where do you actually find blue in the wild? There are almost no blue mammals. There are very few blue plants or flowers. A few birds and butterflies carry the color, but even then, it's not a true pigment. It's an optical illusion caused by the structure of their feathers reflecting light. And what about the sky? The sky is blue, but only to us. To an ancient mind, the sky wasn't a solid blue ceiling. It was an empty void. It changed color constantly, shifting from the bright white of noon to the deep black of midnight, passing through reds and yellows along the way. It had no permanent identity. It didn't need a name. We built the color blue with our minds. We noticed it, we isolated it, we named it, and only then did we allow ourselves to truly see it. And this leaves us with an uncomfortable conclusion. If our ancestors were entirely blind to a fundamental part of our visual world simply because they lacked the framework to see it, what are we missing right now? What gradients of reality are swirling around you at this very moment that you are completely oblivious to? What sounds are you tuning out? What emotions are you ignoring because your language hasn't given you the vocabulary to anchor them to your conscious mind? We look back at the ancient Greeks and find it absurd that they looked at the ocean and saw wine. We find it impossible to imagine a life where the sky isn't blue. But they weren't broken. They were just operating within the boundaries of the world they had constructed. Every day, you move through a universe of infinite complexity, believing that your senses are giving you the full picture. But they aren't. Your brain is editing the script in real time, cutting out the noise, dropping the colors that don't matter, and painting over the gaps with familiar shades. You traded the raw, unmapped chaos of the ancient world for a neat, labeled reality. We gave the world names, and in doing so, we finally made the sky blue. But we never stopped to wonder what other colors we left behind in the dark.